All right, good evening once again. I guess this is going to be our last stream for today, and we came back on the Valentine's Day. We came back to form on Valentine's Day. All right. Okay, so we kind of completed pointers, and that is a brief discussion. I mean, a very detailed discussion of pointers. We saw pointers to functions. We saw pointers to pointers. We saw wild pointers. We saw dangling pointers. We saw how the declaration of a pointer variable and the assignment, and I mean a referencing operator and the dereferencing operator works and all. That's good. So you just need to complete two more topics to complete C, and then you can get the basic idea of recursion. Structures, unions, and enumerations, enums are three user-defined data types in C++. Why did you come to C++ now? User-defined data types. Alright. The syntax is going to be a little bit difficult. Yeah, I don't want to deal with C++ right now. Being very frank, can I report this one? Okay. Yeah, why not? Because if you are open source contributing to people, then that is a good sign, right? Let's report it. Plagiarism factually incorrect. The content is correct, but it is placed in gate notes, and the article is named as structures, unions, and enums in C, but the article is discussing on C++. Not a big mistake, but I favor including an article of action which actually discusses C be better. That works out. Yes, I think that works out. Typecasting in C. Typecasting in C is the process of converting one data type to another data type by the programmer using the casting operator during program design. In typecasting, the destination data type may be smaller than the source data type, and converting the data type to another data type. That's why it is called narrowing conversion. Yeah, widening will be automatically done. Is it? No, implicit data type, okay. Implicit typecasting in C is used to convert the data type of any variable without using the actual value that the variable holds. It performs conversions without altering any of the values which are stored in the data variable. Conversion of lower type to higher type will occur automatically. Integer promotion will be performed first by the compiler. After that, it will determine whether two of the operands have different data types. Using the hierarchy below, the conversion would appear as follows. Okay, that makes sense. There are some cases where if the data type remains unchanged, it can give incorrect output. In such cases, typecasting can help you get the output and reduce the time of compilation. Explicit typecasting, we have to force the conversion between data types. This type of casting is explicitly defined within the program. Float do is equals to a by b. It returns what? It returns 7. So it is 7.0. Here the actual output needed is 7.5, but the result is 7. So to get the correct output, one way to change the data type of the given variable, but correct output can also be done by typecasting. Alright. Okay, this is just a character arithmetic, kind of like what do you call it? ASCII arithmetic, yeah. And there was a program, the expression double converts the variable from type into type double for the operation. C programming, there are 5 built-in typecasting operators. At off, this function is used for converting string data type into a float data type. A to F, okay. A to bool. A, L to A. Uh-huh. I to B A. String. Okay, it doesn't matter. Technical scripter. Typecasting in C programming makes the program very lightweight. Type representation and hierarchies are some features we can take advantage of with the help of typecasting. Typecasting helps programmers to convert one data type into another data type. Okay, we have successfully completed the basic course of C programming. And recursion. Okay. The recursion notes for the GATE exam provides a comprehensive guide to one fundamental concepts in computer science. Recursion specifically tailored to those preparing for the graduate aptitude test. Recursion is a powerful problem-solving technique where a function calls itself during its execution, and it plays a significant role in algorithm design and programming. The process in which a function calls itself directly or indirectly is called recursion. The corresponding function is called a recursive function. Using a recursive function, certain problems can be solved quite easily. Examples of such problems are transfer and in-order, pre-order, tree traversals, DFS of a graph, etc. Recursive function solves a particular problem by solving a copy of itself and smaller subproblems of the original problems. Recursion is an amazing technique with the help of which we can reduce the length of our code and make it easier to read and write. It has certain advantages over the iteration technique, which will be discussed later. A task can be defined with its similar subtask. Recursion is one of the best solutions for it. For example, the factorial of a number. Types of recursion. Recursion are mainly two types depending on whether a function calls itself from within itself or more than one function one function call one another mutually. The first one is called direct recursion and another one is called indirect recursion. Those the two types of recursion are. Direct recursion occurs when a function directly calls itself within the same function. Direct recursion can be further categorized into tail recursion. Is there any advantage of learning all of these categories? Because they help you think more clearly. If a recursive function calling itself and that recursive call is the last statement in the function, then it is known as tail recursion. After the recursive function performs, after that call recursive function performs nothing. The function has to process or perform any operation at the type of calling, and it does nothing at returning time. Time complexity and space complexity. So often, alright. Head recursion. If a recursive function calling itself and the recursive call is the first statement in the function, then it is known as head recursion. There is no statement, no operation before the call. The function does not have to process or perform any operation at the time of calling, and all operations are done at returning time. Okay, it does nothing at the calling time. To understand tree recursion, let's first understand linear recursion. If a recursive function calls itself for one time, then it is known as linear recursion. Otherwise, if a recursive function calls itself for more than one time, it is known as a tree recursion. It is a tree recursion, alright. Function 3 is calling function 2 and function 2. 2 power n. And this recursion, a recursive function will pass the parameter as a recursive call. Recursion inside recursion. In direct recursion and this recursion, there may be more than one functions and they are calling one another in circular manner. At at most, one activation records exist between the current activation record and the activation record for the main. Okay. You are supposed to know what an activation record is. I don't want to do all of this right now. Do you really have a comma here? I do not think so. Gate 2003. I have no idea. You read this one as well, if I'm not wrong. Okay, the notes is bugged, that is for sure. Arrays are fundamental data structures in computer science, and mastering them is crucial for success in the GATE exam. This article aims to improve concise yet comprehensive notes on arrays, covering essential concepts and strategies to help you tackle array-related questions in GATE 2024 exam. Okay. Okay. An array is a collection of items of the same variable type that are stored at contiguous memory locations. That's one of the most popular and simple data structures and is often used to implement other data structures. Each item in an array is indexed starting with 0. Array index in an array elements are identified by their indexes. Array index starts from 0. Array elements are items stored in an array and can be accessed by their index. Array length, the length of the array is determined by the number of elements it can contain. The representation of an array can be defined by its declaration. A declaration means allocating memory for an array of a given size. Arrays can be declared in various ways in different languages. For better illustration, below are some language-specific array declarations. Nice. Nice. However, the above declaration is static or compiled time memory allocation, which means that the array element's memory is allocated when a program is compiled. Here, only a fixed size, i.e., the size that mentioned in the square braces of memory will be allocated for storage. But don't you think it will not don't you think it will not be the same situation as we know the size of the array every time? There might be a case where we do not know the size of the array. If we declare a large size and store a less number of elements, will result in wastage of memory, or either be a case where we declare a lesser size and we won't get enough memory to store the rest of the elements. In such cases, static memory location is not preferred. That is the core computer science philosophy. There are mainly three types of arrays: one-dimensional array, two-dimensional array, and three-dimensional array. One-dimensional array is a list of variables of similar data types. It allows random access and all the elements can be accessed with the help of their index. The size of the array is fixed. For a dynamically sized array, vector can be used in C++. Two-dimensional array is a list of lists of the variables of the same data type. It also allows random access and the elements can be accessed with the help of their index. It can also be seen as a collection of one arrays. It is also known as a matrix. Yes, rows and columns. Its dimension can be increased from 2 to 3 and 4, so on. They all are referred to multidimensional arrays. The most common multidimensional array is a two-dimensional array. Alright. A three-dimensional array has radii and C is a collection of two-dimensional arrays. It can be visualized as multiple 2D arrays stacked on top of each other. Alright. We can declare a 3D array with 2D arrays. Type of data, array name, finding address, of an element in array when it comes to organizing and accessing elements in a multidimensional array. Two prevalent methods are row measure and column measure. Row measure ordering assigns successive elements moving across the rows and then down the next row to successive memory locations. Simple language elements of an array are stored in row-wise fashion. I don't think I really need that. In if an element of an array is stored in a column measure fashion, moving across a column and then to next column, then I don't think I really need that formula unless it was previously tested in Gate. A one-dimensional array or single dimensional array is a type of linear array accessing its elements and also singular subscripts that can either represent a row or column index. Alright. Okay, we will do the numericals later. Okay, people. We covered all of this too. Stacks and queues and then linked list. So we do Tower of Hano and Fibonacci too. Yep, we does that as well. Nice, right? Guess it is good if I sleep right now. Good night, people.